Hey everyone, it's Miss Krieger, obviously. We're going to go over some of your notes today, and we're learning a new topic, which is proving triangles congruent. So this happens if you are given two triangles and some aspects of triangles, like sides or angles that are congruent, and these are the ways to prove that triangles are congruent. So that is our goal here. We're proving triangles congruent. Okay, and then the two that we're going to be learning today are side, 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 and angle, side, angle. Side, angle, side. So side, side, side happens when they give you two sides that are congruent. So this could be like a 3-unit side, okay? And then another two sides that are congruent, maybe a 4, and finally our third side would be congruent, 5. So if we have all three side lengths the same, then the triangles have to be congruent. And then the second one that we're learning today is side, angle, side. So this happens when they give you two sides that are congruent, for instance, a 3-unit side, and another side length that is congruent, maybe a 4-unit side, and an angle between them is also congruent, maybe a 60-degree angle. Okay, that forces that third side to be congruent, and that proves that the two triangles are congruent using side, angle, side. So we'll be learning together angle, side, angle. So that's two angles and an included side. So if they give a, let's say, 40-degree angle is equivalent to another 40-degree angle. A 3-unit side is equivalent to another 3-unit side. Okay, and a 60-degree angle congruent to another 60-degree angle. Okay, that forces the triangles to be congruent. Angle side would be two angles and a side opposite them. So we have two angles that are congruent and a side opposite them, so not the included side. And finally, hypotenuse leg, which is special for right triangles. The hypotenuse of any one leg of a right triangle, the hypotenuse and any one leg. So the hypotenuse and any one leg of a right triangle forces the triangles to be congruent. And then we have a quick recap of yesterday. CPCTC, corresponding parts of congruent triangles are congruent. There you go. That's the fourth time I've said it. If we have triangle ABC is congruent to DEF, then we get to say all these things about the triangles. We can say that segment AB is congruent to DE. And you guys know the rest. We have AC would be congruent to DF. We have BC would be congruent to EF. And then our congruent angles, angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Okay, and then you might want to just highlight these because these are reasons that you'll use in your proofs to prove that sides and angles are congruent. All right, so let's see here. Let's try some proofs. So using side, 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 and side angle side. If all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove triangles are congruent using fewer parts. So let's see. If AB, so we have this AB, is congruent to DE. And we have side BC congruent to EF. So BC is congruent to EF, right? They're the same length. And AC is congruent to DF. Okay, so our third side length is the same as our third side length of the other triangle. Then we get to say that triangle ABC is congruent to triangle DEF. Okay, so let's apply that here. I'm going to make this a thinner pencil so that I can write smaller. We have PQ is congruent to ST. Okay, that's given. We have side QR is congruent to TR, and R is the midpoint of PS. Okay, so we know that R is cutting this PS in half. So that means that PR obviously is the same as SR. But we have to prove it. So we start with PQ is congruent to ST. That's given. QR is congruent to TR. Also given. R is the midpoint of PS. Also given. Okay, so far so good. PR is congruent to SR. Right. So this is new. We said PR is congruent to SR. How did we get that? Okay, we got that from R is the midpoint of PS. So that is definition of midpoint. Sorry for my bad tablet handwriting, but I guess I have bad handwriting all the time, so you guys are probably used to it. Okay, and we have three sides of one triangle congruent to three sides of another triangle. So that is side, side, side. So we proved those triangles to be congruent using side, side, side. All right, let's try another one. We have JL is congruent to NM. K is the midpoint of JN and LM. Okay, so this one's pretty much the same as the one above. Hopefully you guys noticed that the first two statements are given. Okay, and now they're going to prove that JK is congruent to NK. So I already wrote that JK is the one with two marks on it. So JK and NK are congruent because of the definition of midpoint. Okay, they also say that LK is congruent to MK, also definition of midpoint. Triangle JKL is congruent to triangle NKM. So the three sides of one triangle are congruent to the three sides of the other triangle. Okay, so we proved that using side, side, side. All right, I think they get a little bit harder. Here we go. So this is the next page of your notes. They don't give us any statements here. So we always start with our picture. Number 3 starts with AC is congruent to AD. So let's go ahead and mark that. And CB, this little one, is congruent to DB, this little one. Okay, so hopefully you can see that AB is going to be the third side of the triangles, right? And they're congruent. They have to be congruent because AB is the same line segment for both triangles. Okay, so let's start with the first one. We know that we always start with what's given. So AC is congruent to AD. It's given. And yes, I am supposed to be putting these lines over it, but we get kind of lazy in geometry. So up to you. I won't mark you wrong on a test if you just drop some symbols, even though I should. CB is congruent to DB. Also given. Okay, we are going to actually say that AB is congruent to AB. Segment AB is congruent to segment AB because it is the same line for both triangles. Okay, that is a reflexive property. So when something is equal to itself or congruent to itself, it's reflexive. And finally, we have triangle A. Let's say this carefully. If we do triangle ABC, is congruent to triangle. Okay, we have to follow the same path. So we went 3, then 2. Okay, so 3, then 2. That would be ABD. Using side, side, side. Okay, are you getting tired of purple? Let's change the color. I guess it's kind of unnecessary, but fun because I can. Okay, so if two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So if we have side length AB is congruent to side length DE. So if AB is congruent to DE and angle B is congruent to angle E. So the angle B and E have the same angle measure. And our third side, BC, is congruent to EF. So BC is congruent to EF. Then we get to say triangle ABC is congruent to triangle DEF. And this is important. So we have included means the angle between the sides. We have another way of proving using angles. So make sure that if you're using side angle side is the one where the angle is right in between the two sides. So you wouldn't choose A or C or D or F. It has to be B and E. Okay, so some side angle side proofs. Here they give us JM is congruent to LN. So JM is congruent to LN. That's given. They give us angle JMN. So that's this one here, is congruent to LNM. We're trying to prove that the triangles are congruent. So 1 and 2 are given. MN is congruent to NM. So MN of this top triangle, right, is congruent to NM of the bottom triangle. right? That is reflexive. This reflexive property, the triangles are congruent using side, angle, side. We have two sides and the included angle. Okay, number 5, given AB is congruent to CB and BD, so segment BD bisects angle ABC. That means that these angles are the same measure, right? Because BD is cutting it in half. So we have given, and congruent angles. So let's check and make sure this is ABD, that's this angle here, is congruent to CBD. Okay, we know that's true because of the angle bisector. So that's the definition of angle bisector. And then, of course, we have our side here that's shared. BD is congruent to BD. That is reflexive. And we have two sides and an angle between them of two triangles. Therefore, the triangles have to be congruent. So we proved it using side angle side. All right, number 6, V is the midpoint of WZ and XY. So we can say if V is the midpoint of WZ, WV and ZV are congruent. And if it's the midpoint of XY, we can say that XV and YV are congruent. Prove that the triangles are congruent. So we have given WV is congruent to ZV, right? That's the where I marked 1 here. We said that because of the statement V is the midpoint. So that is the definition of midpoint. Okay, the next one says angle WVX. WVX, that's this one here, is congruent to ZVY. ZVY is here. Okay, those are vertical angles. So remember I said you needed to highlight to reference reason why angles are congruent. That is the reason why angles are congruent a lot. Vertical angles are congruent. XV is congruent to YV. That's also the definition of midpoint. That's where I drew 2 lines on my picture here. So definition of midpoint. And finally, the triangles have now been proven congruent by side angle side. If you think that this is super easy and all this practice is redundant, you can, of course, just pause me, do it on your own, and then check your work. I don't mind. Okay, HI is congruent to JG, and HI is parallel to JGJ. Okay, so I'll do my parallel arrows. Okay, so we have given and given. So I want you guys to think of what happens when you have parallel lines. Okay, it needs to be like a mantra Anytime you have parallel lines, you have angle relationships. So your angle relationships are corresponding, alternate interior, alternate exterior, and so on. So they say that GJH, this one, is congruent to IHJ. Okay, so if you can't see it, we have parallel lines cut by a transversal. Okay, so those angles are alternate interior. So alternate, oh, spelled it wrong. Alternate interior angles. Okay, HJ is congruent to JH. Well, yes, obviously, HJ is congruent to JH. So that is reflexive. Okay, and our triangles are congruent based on side, angle, side. We have two sides and an angle between it. Side, angle, side. All right, we're almost done. So, triangle congruency. State whether the triangles could be proven congruent, if possible, by side, 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 or side, angle, side. Then write a congruency statement. Change my color again, because I can. All right. So, we have QY is congruent to KC. We have angle Y is congruent to angle K. And then YT and KP. So this is, hopefully you can see, side, angle, side. And we write a congruency statement. So triangle, let's do QYT is congruent to triangle, what? If I went Q, then Y, then T. Okay, that would be the same as CKP. And the congruency statement matters. All right, number 2. We have two sides. They don't tell us anything else. Nothing is parallel. They don't give us any angles. But we see that this side AC is the same for both triangles. Okay, so this one is side, side, side. And we'll do triangle ACD. ACD. So I went 3, then 2. Okay, is congruent to triangle. What would it be? 3, then 2. So CAB. Okay. Oh, this one's tricky. So we have JMK. That's our first triangle. And LKM is our second triangle. They are overlapping. We have MK in common. Do you guys see it? Side, angle, side. Side, angle, side. So let's say that JMK is congruent to, what would it be? LKM. All right, number 4. We have two sides and not the included angle, right? The included angle would be here. So this one is not congruent. Number 5, side, side, side. Do you see it? Side, side, side. So we'll say triangle CEF. is congruent to triangle DEF. Ooh, parallel lines. Oh, I'm pressing buttons on accident. Sorry. Okay, so parallel lines make angle relationships. Parallel lines make angle relationships. Parallel lines cut by a transversal. Those are alternate interior angles. So this is side, angle, side. We'll say triangle JDA is congruent to triangle MEA. Okay, number 7. Angle, side, side. Is that a proof? No. Okay, obviously. So this one's not congruent. And here we have vertical angles. So we get to say this is side, angle, side. Triangle ACB is congruent to triangle ECD. All right, we're done. You guys can do a proof on your own. Try it. Compare it with your friends next to you, and then you can move on to the next thing. All right, hopefully this was a way to learn.
Good afternoon, Panthers. We do have one announcement this afternoon.
Okay, end of the school day. Have a good day, guys.